Our next speaker in the Kuhn 100 conference is Dr. Mihnea Dobre. Dr. Dobre is an executive director of ICUB, specifically its Humanities Division, the Research Institute in the University of Bucharest. And his talk today is titled Going Beyond Kuhn, Paradigms, Incommensurability, and Textbooks. Mihnea, thanks so much, and please take it away.
Thank you very much, Andrei, and I would like to thank everyone for staying here with us. It's getting dark in Bucharest.
And let me, if I may also interject, a very important fact that I failed to note. Dr. Dobre is a co-organizer of this conference. I'm delighted and grateful he helped me throughout the process. So Mihnea, thanks again.
Okay, thanks, Andrei. I should start by saying that this is a work in progress. And although much of what I'm going to say here goes along nicely with what Dana just said in the conference, we didn't talk about our contributions for this conference. I also think that part of what I'm going to present today fits very nicely with the discussions that we had in Theo's presentation and also in the paper presented by Adam. So let me start. Very brief remarks about Kuhn. I'm not going to say much about Kuhn, but about different ways of moving forward, especially ways of moving forward that are derived from the new scholarship on the early modern studies. I will present the case of the history of philosophy and history of science about the early modern period, and I will try to provide a brief example, which is one textbook on physics at the time of the scientific revolution of the early modern period. Then I will try to reach some sort of conclusions. So as a sort of preamble for what I'm going to say next, I used this passage from John Schuster, who wrote about Kuhn the following lines. I'm not going to read it because I will return to it later on, but I just want to outline the 2 points I'm going to try to make in this presentation. First, the change taking place in the early modernity occurred in natural philosophy, which is to say that history of philosophy and history of science should jointly examine it. Second, the framework of scientific revolutions forces the historian to think in some restrictive historiographical frameworks, which might hinder one's research. And I'll try to provide an example for the latter. But due to time constraints, I'm afraid I'll only have to sketch it. So if you want, we can discuss this during the Q&A session. Now, since this is not the first paper in the conference to discuss Thomas Kuhn's views, I'll take it for granted that I do not need to introduce and to repeat the key points about his book, The Structure of Scientific Revolutions. I'm sure that the book is familiar to all of you in various formats and editions. Some of the title pages of such editions can be seen on the screen. The main concepts I will refer to in this talk should be equally familiar: scientific revolution, paradigms, and incommensurability. But if we try to make a quick reconstruction of Kuhn's theory about scientific change, is the one that you can see in this diagram. It starts from the concept of a paradigm which characterizes the so-called normal science. As the name suggests, it is the regular course in which science is practiced. Problems are solved as puzzles, and the progress is considered cumulative. A crisis occurs when the regular problems of the normal science turns into anomalies. With the growth of anomalies, science turns into a period of extraordinary science, which leads eventually to a new paradigm. As already discussed in the conference, the two paradigms, the old and the new ones, are competing to provide the accepted explanation in that particular science. Here is where the concept of incommensurability comes into play, as it describes the relation between the two paradigms. In short, they fail to translate completely one into the language of the other. Hence, they are incommensurable. A fruitful playground for philosophers of science, historians of science, or historians of philosophy to discuss about scientific change was and still is the early modern period. Even before Kuhn, authors such as Alexandre Poiret or George Sarton, to name just the two of them to whom I'll return in the following minutes, have thematized the problem of the revolution in science, the very moment of birth of the modern science. Here on the screen, you can see some books discussing this topic, including a very recent edited volume about the scientific revolution of the early modern period. Now, the historian needs to ask, what was changing? And then observe carefully all the written and material sources of the period. The most obvious problem, and we should be all familiar with it by now, as this has been extensively discussed in the past few decades, is that the term science is somehow forced into the types of scientific practices of the 17th and 18th centuries. At that time, philosophy reigned supreme, and it was one of its branches dealing with the study of natural bodies insofar as they are natural, as the scholastics like to define it. That is the closest term to the modern word science. It was the discipline of natural philosophy that somehow managed to produce what we are calling modern science, with the transformative moment leading to this change being called the scientific revolution. I do realize this characterization is sketchy, yet I think it helps me to slowly make the transition towards a key question in today's talk: how to explain the change observed in the early modern period. And I think the answer is not easy. Although it can be summarized by a simple phrase, the most significant change for any reconstruction of scientific change in the early modern period took place in natural philosophy. We can go along with Gary Hadfield's question, was the scientific revolution really a revolution in science? We can inquire further with Christoph Lüthi, what to do with 17th century natural philosophy. But what one needs to realize by looking at these recent approaches to the problem is the great emphasis on the interplay between science and philosophy, such that changes in one of the disciplines are often reflected in the other, especially when natural philosophy is examined. Such that Lisa Shapiro's Revisiting the Early Modern Philosophical Canon and Christian Mercer's The Contextualist Revolution in the Early Modern Philosophy reveal a path worth taking, a more careful examination of the various changes in early modern natural philosophy, one that operates with more historical actors beyond the canonical figures and is more sensible to challenges of the historiographical categories employed. Now, the traditional story about the early modern period would indicate a revolution or several revolutions, if you want to broaden the perspective, which was or were due to the various transitions from general explanatory philosophical systems, such as the Aristotelian, Cartesian, we've heard about the Baconian, and later the Newtonian. Other philosophical explanations can be included in the list. Another traditional topic discussed in the literature on the scientific revolution concerns the transformations related to the early modern matter theories, to new explanations for causality, the role of God in relation to nature, the birth of the new disciplines, the emergence of new methods, such as the experimental techniques of the early modern period, and the establishment of new relations between traditional disciplines. These are some of the most obvious topics discussed in the literature about the scientific revolution, and I wanted to remind you about them just because of a simple observation I want to make. Some of them are deeply philosophical or even theological. So broadening the spectrum of the revolution is one of the most important methodological aspects that one needs to take into account. Now, just to put a neat diagram in front of you, a simplified account of the traditional story is that Newtonianism is the winner of the scientific revolution, obscuring the Aristotelian and Cartesian explanations as mere pre-paradigmatic cases before the emergence of the modern science. Please note the Cartesianism in the middle. Due to this intermediate position, Cartesianism tends to be disregarded. It is either placed in a philosophical discourse, so part of the history of philosophy proper, or when it is considered as part of the emergence of Newtonianism, it is described as a caricature in the history of science, a passing phase which was quickly invalidated by Newton and the Newtonians. I find both approaches limitative, and one of the main reasons is what I've said earlier. The change in the early modern period, which is traditionally described as the scientific revolution, took place in natural philosophy. So let me now try to build my case and provide a different reconstruction of this diagram. The quote you see on the screen is from a book written by the 19th century historian of philosophy, Francisque Bouillet, Histoire et critique de la révolution cartésienne. Just like Thomas Kuhn outlined some of his views of the structure of the scientific revolution in an earlier book, The Copernican Revolution, Bouillet too produced this book some years in advance of his celebrated history of Cartesian philosophy. But the quote on the screen has a different purpose than this parallel with Kuhn. It helps me to make the case for the natural philosophy, and in particular for the role of Cartesian natural philosophy. Bouillet claims nothing less than, quote, following the Socratic revolution which gave birth both to Plato and Aristotle, the Cartesian revolution is the most fertile and most powerful that presents in the history of philosophy. There is no other that had attracted more major systems, which has engaged more men of genius in its movement, end of quote. The view exposed at the very beginning of his book is further explained by Bouillet. And this is the new quote you should see on the screen. Indeed, in philosophy, Descartes is a revolutionary. Its mission is not to continue the past, in other words, the scholastic philosophy, but to break with it and to replace it with a new philosophy. Now, what does it mean that Descartes is revolutionary in philosophy? As tempting as this might be, I'm not planning to search an answer in the 19th century scholarship. Instead, I'll use one of the more recent approaches. In Dan Garber's book, Descartes' Metaphysical Physics of 1992, one finds the following explanation. In demanding that metaphysics must precede physics, in arguing that physics, as Descartes understood that discipline must be grounded in some sense in metaphysics, in knowledge of God and the soul, Descartes is stepping clearly outside of the tradition. But however important and revolutionary this view may have been for Descartes, and however important it may be to our understanding of his position in the history of philosophy, it is interesting to point out that if it was a revolution, it went largely unnoticed by those against whom it was directed. Furthermore, the doctrine of the priority of metaphysics was unnoticed or unwelcomed by many of the party of the moderns, both Cartesians and non-Cartesians, whom it was supposed to place in the ascendancy. End of quote. Compared to Bouillet's position, this expresses a more nuanced view about the novelty of Descartes' philosophical thought and a more nuanced view about the relation between Cartesianism and the scholastics' doctrines. As you can see in the middle of the screen, it's that part that starts with, but however important and revolutionary this view may have been for Descartes, and ends up with, it is interesting to point out that if it was a revolution, it went largely unnoticed by those against whom it was directed. It is, however, a momentous change, which has at least two characteristics that I'll discuss further. One, it was a change largely unnoticed by the competing explanatory model, that of the scholastics, and the other characteristic is that it occurred in natural philosophy. So, as a short recap, please remember the passage from John Schuster in which he identified early modern natural philosophy as an institution of change. Natural philosophy is a much broader framework, including metaphysical foundations, theories derived from mixed mathematics tradition, causal explanations, experimentation, and the use of instruments, and many other systems of practices and theories, which are difficult to classify from the point of view of the current scientific theories and disciplines. Now, I'll move to the question of paradigms. It is very appealing to reconstruct what I've presented so far in terms of paradigmatic shifts. The Aristotelian paradigm is replaced for a short run by the Cartesian, which is quickly followed by the Newtonian. This will also portray some other, and in a sense, more minute transformations, which are depicted on the timeline at the bottom of the screen. The emerging new philosophy of the 17th century paved the way to the experimental philosophy, and in the early 18th century produced the spread of Newtonianism. So, it is a paradigmatic change in natural philosophy, which mostly occurred at the end of the 17th century and the beginning of the 18th. A legitimate question in this respect is, who were the players in this game of paradigmatic change? So let me introduce one historical figure. I'm sure that his name is not familiar to most of you, but suffices to say that he was a Cartesian experimentalist and the author of a famous treatise on physics. Writing in 1671, in the preface to his Traité de Physique, a wonderful text, by the way, which I've recently co-edited and published in open access with 3 colleagues from Bucharest. So writing this text, Jacques Rouault deplored the status of natural philosophy. He says, "When I came to consider philosophy, particularly natural philosophy, I was very much surprised to see it so barren as not to have produced any fruit, insomuch that 20 ages have passed without any new discovery made in it. For this reason, he took the task to write a complete treatise on natural philosophy, one in which Cartesian explanations are joined with experiments, and the reader is introduced to general problems in natural philosophy, cosmology, the earthly phenomena, and medicine." What is interesting about this book is the favorable reception it received from the moment of its publication in 1671 up to the mid-18th century. As other scholars have noticed, Rouault's treatise was the leading textbook of its time. It was used at the universities of Utrecht, Frankfurt, Groningen, Louvain, and Leiden, according to Schuller, or the standing text for lectures at Cambridge, according to Denis Deschamps. But There is yet another curious element in the reception of this book. In 1697, at Cambridge, Samuel Clarke translated Rowe's treatise in Latin, replacing an early Latin edition, which was from 1674. Clarke edition was improved several times with new comments. You have the dates on the screen, so I won't read them. And this is important because it shows that a later Newtonian, like Clarke, spent quite some time translating and commenting Rowe's text. Of course, Rowe's treatise was a popular textbook on physics. But nonetheless, some of the most popular editions of the book were produced by a Newtonian figure, which is quite disturbing for historians of science discussing this period. I'll return to this point later on. But for the moment, I want to emphasize that Clarke's Rowe is a mixture of at least two natural philosophical views. And it is in this context that I want to refresh you on another section of the quote from John Schuster displayed in the beginning. If we investigate early modern textbooks, we can discover a feature nicely illustrated by Clarke's Rowe. They contribute to a tradition modifying, yet they are non-revolutionary treatises on natural philosophy. With this in mind, I'll move now to discuss some of the historian's tools, which is to say the historiographical categories and the framework in which one's explanation can be furnished. On this slide, you should see George Sarton presenting the good reception of Rowe's treatise in a Newtonian context. Quote, Rowe's success was not diminished by the introduction of Newtonianism, but increased, and his Cartesian textbook continued to be reprinted until 12 years after the death of Newton in very old age, or until more than half a century after the first edition of the Principia. End of quote. This is all nice and fine, and it seems to fit well in the aforementioned schemes. Yet, as the timeline at the bottom of the screen shows, there is something odd with chronology. If Descartes' most important work in natural philosophy, The Principles of Philosophy, was published in 1644, and Newton's celebrated Philosophiae Naturalis Principia Mathematica appeared in 1687, why on earth was Rowe's treatise, which was published in 1671, so successful? Sarton provides the following answer. That aberration appeared in its most curious form, not in France, but in England, in the very University of Cambridge where Newton had been teaching. Samuel Clarke of Norwich, who was to distinguish himself later as a theologian and metaphysician, began his career as a mathematician and natural philosopher. Please note especially the opening of this passage. So why calling Rowe's treatise an aberration? I consider that Sarton's answer offers a solution to several challenges that every historian of philosophy and science is facing. These are expressed on the screen in form of various questions, such as how to describe the change, or what is the desired level of detail. While these two questions are more about the focal point, broader or narrow, focused on more minute aspects of change or large-scale changes in different disciplines, there are other questions pointing to another aspect. For example, if one asks the question about what paradigms are into play, for the case examined so far, one will have to address the issue of Cartesians versus Newtonians, in this particular case, Rowe versus Clarke. And the same problem is extended in the case of incommensurability. what to do with the expounders of the two incommensurable paradigms. In other words, the interpretative framework relies on the assumption that two competing and incommensurable paradigms are present in Clarke's role. The later aspect is perfectly illustrated by reading Sarton's text further. Sarton says, now, the Rowe-Clarke treatise could be defined not as a Cartesian Newtonian textbook. That would be nonsense, but as a Cartesian textbook including in the footnotes a Newtonian refutation. End of quote. Please pay attention to the text in italics. A joint label Cartesian Newtonian is a nonsense at the end of inquiry. In other words, it is an aberration to be avoided by the historian. But why should it be so? What if we overlap the diagram of paradigmatic change we've seen earlier in the case of Kuhn with the case presented a few moments ago? What would happen if we take Clarke's role as a legitimate anomaly worth studying as a Cartesian Newtonian textbook? I'm slowly approaching the concluding part of my paper. Eclectic authors, historical figures combining and using ancient authors with modern ones, diverse methodologies, and so on. The challenge is how to define anomalies and aberrations in the history of science and reflect on the one hand the diversity of the early modern views and practices, while on the other hand reconstructing them in their own right and not as caricatures of something we conceive as not being possible. In other words, the challenge is to embrace or at least to deal with the mess of the object of study. And there are several ways to go from here. One is to devise more accurate chronologies and to apply them to more diverse cultural and geographical spaces. Another option is to constantly shift the focal point from large-scale transformations to smaller details and the other way around. An exercise that, when practiced constantly, can provide more meaningful ways to examine and to explain scientific change. And let me offer one final example to illustrate these tentative conclusions. For the case discussed in the current paper, chronology will permit a new periodization of Clarke's life, from the early views in natural philosophy to his transition to Newtonianism. So to assume that Clarke was not always the Newtonian of the correspondence with Leibniz, for example. But this is a hard assumption to make, especially when one is accustomed to traditional stories, such as the backward reading imposed early on by William Whiston, which I want to present in the next 2 slides. This is a passage written by Whiston in 1730. I'm not going to read it. This passage was printed in the memoir dedicated to the works of Samuel Clarke, published immediately after Samuel's death. Please pay attention to the dates and the names marked on the screen. In 1697, Whiston met Clarke, a young Cambridge graduate at that time, who was translating Rowe's textbook on physics, which was also published in 1697. And the interesting part is on the next slide. During the aforementioned meeting, Whiston recalls perfectly well, in 1730, of course, that he said precisely the following words in 1697, and please note that Whiston quotes himself in this passage. Since the youth of the university must have at present some system of natural philosophy for their studies and exercises, and since the true system of Sir Isaac Newton was not yet made easy enough for that purpose, it was not improper for their sakes yet to translate and use the system of Rowe, who was esteemed the best expositor of Descartes. But that as soon as Sir Isaac Newton's philosophy came to be better known, that ought only to be taught, and the other dropped. End of quote. This looks more like a backwards reflection of what was Clarke's main achievement in Wisdom's view, but not as a prophetic advice uttered in front of the young graduate in 1697. It is a foundational story for the Newtonianism of the 18th century, but it is precisely due to this context in which it occurred that it cannot be taken for granted. It obscures some of the rich natural philosophical debates of the period because it subsumes them to the winning party, the Newtonian. Instead, the historian of philosophy and science should delve more into contextual details, as for example, this article written by Stefan Duchesne and Yip van Bessel. Newtonian paradigm was not yet imposed, not even among the fellow English scholars. And for a long time, at least between the publication of the first edition of the Principia in 1697 and the second one in 1713, relevant questions in natural philosophy have raised more problems than finding a solution. Now, I do not want to conclude in the somber manner, but Dmitry Levitin's recent remark you see on the screen might express a side of the story. For Levitin, quote, "We must recognize the immensity of the change that had occurred in Europeans' conceptions of what was legitimate knowledge over the previous 2 centuries, a change in which philosophy was undeniably the loser. For Kuhn, this was the legacy of a Newtonian paradigm shift." End of quote. If for Kuhn the legacy of a Newtonian paradigm shift might have turned philosophy into a loser, this is due to the very neglect of natural philosophy as part of the reconstruction of the relevant change of the early modern thought. So what I've tried to argue during this talk is that we need to diversify and broaden the perspective, to examine books and practices that are currently neglected because they fell outside of the current historiographical categories. On the screen, you see the title page of 3 books, almost randomly selected from the plethora of early modern writings dealing with joint approaches, old and new, in natural philosophy. So combining and mixing views from different paradigms. Now the conclusion. As mentioned in the beginning, this is a work in progress. But I hope I did manage to argue that paradigms and incommensurability are defined by historiographical categories. And what we need to do as scholars is to constantly reshape our historiographical lenses. Kuhn was educated in a tradition exposed by Poiret and Sarton, among others. And he was providing an answer to the problems raised in their approaches. For my talk, I've been referring to Sarton's claims about Clarke's role as an aberration, one that defies the neat categories of Cartesian and Newtonian. This approach obscures a variety of questions pertaining to the spread of Cartesianism, the variety of Cartesian natural philosophies, and please note the plural, and the slow adoption of Newtonianism. For a number of years, they were not legitimate questions for scholars. So, in this sense, perhaps it is time to move beyond Kuhn and the old historiographies of science and philosophy, on which he built his theory, and start developing new historiographical lenses. One way is to make the historiographical categories more flexible, while exploring the early modern natural philosophical writings and practices, even if they are more messy, fragmentary, or too difficult to characterize in one word. So why not? Thank you very much.
Thank you so much to Mihnea, and I'm sure everyone in the audience joins me in applauding your work. Next up, Q&A. We already have a question from Theo. Professor Arbatis, please go ahead.
Thank you so much, Mihnea. That was really, really interesting and very, very thought-provoking. I have a question of clarification first and then a more general remark. The question of clarification has to do with incommensurability, the incommensurability between the Cartesian and the Newtonian paradigms. And it's not clear to me why those paradigms, if you want to call them that, were incommensurable. I mean, in what sense were they incommensurable? So that's the clarification question. The more general remark has to do with the mess. It's I mean, historians have gotten used to being in a mess or to dealing with a mess. And I was wondering whether your suggestion to try to come to terms with a mess, whether that could be seen as in a Kuhnian spirit, because if you remember, Kuhn suggested that we should our starting point should be nonsense. We should, when we look at passages that don't make sense, these provide points of entry into an alien world. And once we come to terms with nonsense, then we understand that world. And so I was wondering whether, again, other things being equal, the same applies to this case. You see a mess, something that doesn't make sense from the point of view of the older historiography, and the desideratum is to come to terms with the mess, come up with categories that will dispel the mess or will impose order on the mess and make it understandable, so on. So that, thank you so much again.
Thank you very much for both questions. I'll start with the first, and I'll try to provide a very simple answer to it, and then I'll move to the second. I think the best way to present the two paradigms, Cartesianism and Newtonianism, as incommensurable, is to look at what is called mathematization, and to say that Cartesianism cannot incorporate the kind of high-level mathematics that Newton has in natural philosophy. For example, in the case of the celestial motion, to apply mathematics for the vortex theory, that's something very difficult to do, and the mathematicians who are trying to do this had great difficulties. So in this sense, it's very difficult to make it mathematical. That would be the simple answer. As for the general remark concerning the mess, I think it was a bit provocative to use the word mess for this, because of course there are many other options, complexity, and probably this is just a choice I've made because I wanted to put into the spotlight works that are not so much frequented by scholars, thinkers who are trying to combine different views coming from the ancient authors together with some of the moderns, to do some experiments, but at the same time to reject new forms of experimentation. I think there is something rich we can uncover by looking at this kind of different mixtures of natural philosophical writings combined with natural philosophical practices. So that's why I opted for the mess. But I do agree with you that it's important to start looking at what seems to be a nonsense. So in a way, Sarton was already passé at that time. Thanks.
Thanks so much for the question and answer. Next up, we have a question from Kuhn. Please go ahead.
Yeah, thank you so much, Dr. Dobre. I really enjoyed this talk, and I'm very sympathetic to a lot of things that you have said. This is not so much your questions, but a kind of as a comment, not to add more mess into the picture because you already had a lot here. But in the 18th century, I wonder how you will make of cases like Euler, or so who's someone, who's on the one hand committed to the Cartesian mechanical philosophy, insisting that everything has to be explained in terms of matter and motion, right? So in fact, he even developed this ether theory of gravity in his lifetime to try to, recover Newtonian gravity. But on the other hand, there is no denying that he was a very important figure in the so-called Newtonian tradition. I know that you don't like those, maybe you won't like those big label term, but, he is someone who has contributed a lot in the founding and the conceptualizations of the Newtonian science. So it seems like for a figure like this, it would be even more difficult if we look at the details in his theorizing, because he seems to have both the Cartesian elements that's very prominent and also the Newtonian features in his theory. So I wonder how you would make of cases like this, where it seems to be even messier than Rohde and Clark. Thank you.
Thank you. I must clarify something. I'm not against using the labels, but I'm trying to argue that they need to stay flexible, depending on the kind of account we want to make. So it depends a lot on what we want to say at a particular point and what kind of argument we want to make. So it might be useful to go back even to the larger categories and to historiographical categories and to use them in one paper or in a longer argument. Thank you very much for bringing Euler into the discussion. I think there are many figures of the period who were trying to do something similar, to try to take some of the things that they considered to be good in Newton and combine with other things that they considered to be good in Descartes or in others. Christian Huygens would be another good example in this respect. So I think this is the kind of richness that we need to uncover, to look at this kind of mixed elements coming into play, because they are not necessarily scientific as we would call them today. They're also philosophical, and some of accepting some of these philosophical principles would mean that they are prone to one of the natural philosophical explanations available at that time. So, for example, Cartesian natural philosophical explanation was very successful in the sense that it managed to explain many phenomena, although the details were not very well explained by the theory. or even if mathematics was not well applied, as I've tried to answer earlier in the case of the vortex theory of planetary motion, intuitively, Cartesian cosmology was providing a neat image of what was going on in the universe. So yeah, I think it's very important to look at this kind of different borrowings, appropriation, and attempts to provide a new system, a new natural philosophical explanation. But this is perhaps because of the very nature of natural philosophy, which is combining all these kind of elements coming from philosophy, but also experiments and many other things that are somehow lost by the modern science.
All right, thanks so much, Dr. Q, and to Dr. Dobre for the answer. A new question, and we're drawing close to the end here, but there's a new question from Dr. Grigore Vida. Grigore, please go ahead.
Thank you, Andrei. It's rather a side question. I would be curious what you make of Levitin's thesis that there was an emancipation of philosophy after Newton. What do you make of this?
Probably we need to discuss more about this. The book is huge, as you know. So yeah, it's worth discussing more about that, and not in the last minute that we have in this conference.
Is there a one-liner, an elevator speech by way of answering to Dr. Vida's question, or should that be postponed?
I think we can postpone it for now, but I will have the chance to discuss with Grigore later on. So,
and that is excellent. That means the question is deep enough to be worth exploring a future project. Thanks so much to both of you. Is there any last comment, question, or rejoinder taking a stand with respect to Dr. Dobre's presentation? Please don't hesitate. This would be the ideal time to do it.
Yeah, I just want to say that I'm all for, uncovering the richness in the history of science and the history of philosophy. This is something that I think will open up a lot of research avenues. Super good news for the young scholars like me, and also a lot of people who wanted to know the complexity of this history. So thank you very much for this project.
And thank you so much. I'd like to be in solidarity with Dr. Q and on behalf of the young scholars. Thanks again. Please join me in thanking Dr. Dobre for a wonderful talk.
Thank you.